Problem 8 gives us a graph. So there's a couple things you need to make sure as soon as you see a graph on an exam. There's a couple things you need to check for immediately before you start proceeding answering the questions. First is, what is the graph that you were looking at? Like, double and triple check. Is this the derivative? Is this the original function, right? Is this the second derivative? What am I looking at? Because it's going to totally change the way you read the picture. The next thing you need to do is you need to verify the grid, right? So this graph clearly states we're looking at the derivative of f of x. We've even written df dx here, but I might take it one step further and just, in my own handwriting, write f prime of x because I know I checked that, right? The next thing is look at the grid lines. This one told us the grid lines are 1 unit apart because we can see there are no numbers here. And so I might even write down that's the origin. If they're not labeled, I might go that extra mile and label them because I just don't want to make a mistake when I read this picture. The third thing you absolutely need to check for is, what is the domain of the function you're looking at? Because sometimes the lines go off the page. So it's implied that this is going all the way to infinity, right? Or all the way to negative infinity. This problem explicitly called out that the domain is 0 to 7. Notice that that's an open interval. So these two open circles here at 0 and 7, might be tempting when we start going through these problems to put 0 or 7 as an answer, but we can't because 0 and 7 are not in the domain. So what are you looking at the graph of? What are the grid line? If they're not labeled, what's the thing? Don't assume they're 1, 1, 1. It could be 5, 10, 15, you know, depending on how we count it. And what is the domain of what I'm looking at? What world do I live in to answer these questions? So the first question says determine all the critical points of f. So they want us to look at the graph of the derivative, find the critical numbers of the original function f. So we do this the same way we would algebraically, but now we just read them off the graph. So on the previous problem, we found critical values by finding out where the derivative was 0 and where the derivative did not exist. So if I look at this picture, the derivative, because this is the graph of the derivative, is 0 anywhere it crosses the x-axis, right? Because that means for any one of these values, I go down and it's giving me the slope of the original function at that point. So it's 0 right here. There's a CV. It's 0 right here. And it's 0 right here. So my answers are going to be x is 1, 3, and 6, right? By labeling those lines, I was easily able to pick them up. I didn't have to worry about counting wrong. Now, a very common wrong answer is somebody might try to say, right, f prime does not exist at x equals 0 and 7, and that would be wrong for this function because they're not in the domain. And that's why if you didn't do that domain check and check that this was open, right, you might try to say, oh, I see an open circle, the derivative doesn't exist there, okay? If this were closed, if the function did exist, then we would include those values. So this would be completely wrong because it's not in the domain of the original function. So the correct answer is just 1, 3, and 6. All right, determine the intervals on which f of x is increasing. So f of x is increasing when the first derivative is positive. So if we go back up and look at our graph, the derivative is positive anywhere it is above the x-axis, right? Because these are all the positive values. So I'm going to read this differently. If you were looking at f, you would look for where the graph is like increasing, right? But this is the derivative. We just want to know where it's positive. So if I come down here, the graph is above the x-axis from 0 to 1 and from 6 to 7. So personally, I would not include, the answer key says they'll allow you to include 1 and 6, but they'll take it not included. I personally would not include 1 or 6 with brackets because it's 0 at those locations, and 0 is not positive or negative. It's neutral, right? So the function's actually going to have some kind of turning point or something else is going on there. So we would want to take those. So without any other information to go by, you know, I would just leave it open if I wasn't sure. All right. Determine all the values of x where f has a local minimum. So we know that a local minimum occurs, right? If we were doing this using our first derivative test, the local minimum occurs when the graph goes from increasing or decreasing to increasing, right? So the function's doing that. So I need to see where f prime changes sign from negative to positive. So if we go back up to our graph, where does it go from the negative territory into the positive territory? So here it's positive to negative. Here it goes negative to 0, but then it stays negative, and here it goes from negative to positive. So the only local minimum is at x equals 6. Determine all the intervals on which f is concave up. So f is concave up when the second derivative is positive. So it's going to be where the slope of f prime is positive. So because I'm looking at the derivative graph, I want to know about the derivative of the derivative. So we go back up here, and now we would look at the slope of the tangent line. So if we kind of use my pen here as the tangent line slope, well, we can see this line has a negative slope. It's got negative slope. Then it comes around, it's 0 here, and then it suddenly has a positive slope. So there's a positive second derivative from here to here, right? Because then it turns again. So this is going to indicate the original graph was concave up. So this is going to be from 2 to 3. And then I'm going to go back to the graph. We've got negative slope, right? It goes 0 again, and then it becomes positive all the way to here. So at 5 to 7, it's positive. And once again, without more information or more analysis, I would just keep it open because we will accept the open intervals for this, and I think that's just the safer bet. You don't ever want to accidentally include something if you're not 100% positive you're allowed to include it. And also here I would be hesitant to include it because the slope is 0 at those turning points, and 0 is not really positive.